Yes, thank you.
Yeah, thank you, Meenakshi. Thank you for the introduction and good afternoon and welcome everyone. Hope my screen is visible in the presentation mode.
Yes, yes.
Yeah, thank you. So, my name is Saili Satokar and I am a team member at National Resource Center for EHR Standards. And today's session will be mainly focusing on, understanding the concept behind how ABDM HI types, we call as health information types or clinical artifacts, are designed, how those artifacts are, uh, uh, developed using standards, how we can create those artifact programmatically, its validation, its serialization. So we will be looking into all those points in detail. So giving to the outline of today's session, I will introduce a bit about NRCS for those who are new and know more about standards. So I will brief about NRCS and its activities. Next, the basic focus will be on FHIR implementation guide, which is basic of today's discussion. Just a minute. Yes, which is the basic of today's discussion. Then I will take you through the complete detailed understanding of the structure of each and every HI types, how it is designed, and the structural overview of it. Then I will give you the release updates of the new build that is hosted on the 15th March. That is build 2.5.0 of implementation guide, what new we have included in it. Then I will brief you about ABDM FHIR R4 usage samples, which are the code snippets which will help implementers, developers to refer to and create these HI types programmatically. And my colleague Gaurav will actually demonstrate how to create programmatically using ID to all these points that are mentioned: creation, serialization, its validation. Again, if already object is there, so how we can parse and read that HI types. So, talking about the National Resource Center for EHR Standards, that is NRCS, it is a center for excellence established at CDAC Pune by Ministry of Health and Government of India. So, as you must have aware of, we have EHR standards notified in 2016. So, the center at CDAC Pune helps you throughout your journey of standardization of the application, healthcare application. So we provide assistance in all possible ways. So we provide training and education to understand basics and all the details of the standards, those standards can be utilized. We have tools for you, which are free and open source tools and technologies, which will act as an intermediate tool and help you to integrate those standards. We provide national releases, so which can be referred for the any national needs. So FHIR implementation guide that we have developed is comes under national releases, and for ABDM use case, we have developed and hosted this FHIR implementation guide. So we also provide implementation support in order to, if implementers get stuck in understanding or where that standard fits in their application. So we help in that, and for that we have all liaison with all the standard development organization, and we also work with the National E-Health Agency for assistance in ABDM. So talking about the FHIR implementation guide, so FHIR implementation guide is actually represents how FHIR, that is the fast healthcare interoperability resource standard, used for the use case for ABDM. So to make this ecosystem standard adherent, we have identified FHIR as an FHIR as a standards. So how that standard fits in the ABDM. So whenever that data, whatever data that is getting exchanged, that has to be standardized, and FHIR plays a role there. So whatever data is getting exchanged is FHIR enabled, and how that data looks like, how, what are rules, how the scope of usage is there. So that is being delivered by this implementation guide, which is a hosted website. So basically all these records that are designed for ABDM are aims to cover most of the health record document sharing. So whenever we are going from one healthcare provider to another healthcare provider and data is getting generated, so that data we have assumed like a health record for the continuum of the care. So to complete that health cycle, initially these all of these HI types or clinical artifacts are identified, and to have standard in place, we have FHIR as a structure standard for the exchange, and the internal standards also where it is for terminology we are using SNOMED City for Loink laboratory. So we have different standard in place in that FHIR structure. So let's have a for ABDM use case, let's understand how we are fitting these document record in the ABDM ecosystem with FHIR. So when we talk about the structural overview of every HI types, each of the HI type is designed in a way that it represents a healthcare document that supports a continuum of care for an individual, and that can be handed over to a patient or for concerned person in a human readable format. So each HI type symbolizes a representation for human, and it is not just for sake of transferring. So each of the document record, diagnostic report, discharge summary, prescription record, immunization record, these are the documents which can be actually handed over to a patient, and which can be standardized also. So every document here or document carries a collection of information that, now if you see, all of these documents are having some metadata associated with it and some clinical information sections. And for some use cases, we have a document where we can simply scan document and upload it. So this is the way that we have thought of we should have a record with metadata, with clinical data in it. So whenever we talk about different HI types, we have diagnostic report for all the labs and radiology reports. We have discharge summary for the inpatient encounter. So depending on the encounter, these record types are generated. So for prescription record, it is generated for the encounter where outpatient encounter is there, and a consultation note is also generated at the same time. Then we have wellness record. We have wellness record which we which records that include whatever immunization that is administered, and it also has the provision to upload a certificate associated with it. Sorry, immunization record. Then wellness record is something like that if we there is a use case where we are monitoring our health at home using some devices, so that are there. So it includes vital signs, body measurements, woman health and lifestyle, where you can have your diet and other factors recorded, BP and everything with whatever home devices that are available here, and a health record document which is specially designed for the PHR app. So all these records are designed considering this can be handed over to a patient and to get the continuity of care. So while designing these clinical artifacts, so we have some uh, some uh, considerations or designing aspects with us. So like there is a lot of data available already, so we were having this concern how to upload already available data. So we have provision of scan document, so that can be uploaded for the existing data, for the historic data. Then we have this scenario where people may not be able to have a terminology enabled data directly. So we have this provision that we have structured data in a way that it has a metadata and a structure and categorized clinical information, where structure data is categorized correctly, and that can be filled by the record generator without any terminology support. So that provision is there. And the most important and the use case that we always encourage is fully structured data with coding and technology, where data is structured with terminology enabled, like SNOMED, CT and lawing. So these are the design considerations that we had while generating those clinical artifacts. So to make it enable, so how to make it enable in a standards, how we are actually mapping this to the standard. So we have identified FHIR as a standards, and as you must be aware, and we had already sessions on FHIR. So FHIR has number of list of resources. So we have identified what all resources can be considered. So there are these two foundation resources that we consider. Were many resources which which were having which were allowing the use case of collecting multiple resources. As you are aware, there is metadata also, and there are different information which can be identified, different use resources, like patient is there, encounter is there, condition is there, procedure is there, organization is there. So all of these resources has to be together. So we have identified these foundation resources where composition defines actually forms a clinical document, and it defines the structure and narrative content necessary for a document. Actually, it provides single coherent statement of meaning that provides a single context also. Composition basically makes a foundation of a document. It provides information related to subject, author, who is assisted, and it also gives you the structure overview. So by defining the series of sections, so composition defines what all information will be categorized under what sections. And if you see composition, however, composition alone does not establish a document. It does not, if you just populate a composition resource, it will not make a document. So for that purpose, bundle resource is considered, which actually acts as a container for collection of resources here. So the full content of document is expressed using bundle. So see, we have a composition which actually defining its structure, and to follow that structure, to bundle all of the resources together, we have bundle resource separately. So a bundle of type document will include a composition resource, and whatever resources that are referred in the composition resource directly or indirectly, that will be included in the bundle. So these are the two main resources that are foundation resources of FHIR that are considered for our use case. Now let's understand all of it, what I have explained right now graphically. where suppose if we need to populate a OP consultation note, and this block represents a bundle. Okay, so bundle, if we say, so resource type will be bundle, some ID will be there, a bundle of type document. Whenever we say a bundle of type document, it states some rules. So to represent that document, as I mentioned, the first entry of the bundle should be composition. And as I explained, what composition tells, it tells about, it gives you the structure of that bundle, and it gives you, it forms a context of that, excuse me, it gives the context of that record, you know, like what is the subject, what is the author, what type of document record is it is there, what is the title in a human readable format, and what all sections that document is having. So OP consult note is a document of type consult report, and these are the sections which are there. Now every element, these represent the subject, encounter, author, type. These are the elements of the composition. When you see a composition resource, you will find these elements, and element will refer to further resources, FHIR resources. So subject is element refers patient resource. Encounter element refers to the encounter. So all details of the patient will be there in the patient resource. Details of the encounter will be there in the encounter resource. Likewise, each section refers to some resources to categorize informations. Like chief complaints is category, a section there which is represented by a condition resource. Physical examination is a section which refers observation resource. So a bundle, whenever OP consult note bundle will be generated of type document, first entry will be composition, and later whatever resources that are referred in that composition or anywhere will be there in that bundle entry, next entry. So patient entry will be there, resource will be there, condition resource will be there, procedures. So this is how your complete document bundle will be formed of any type. Right here we are demonstrating as a OP consult note. So now whenever now this is one of the standardization where we have achieved a specific structure, right? Whenever you will see condition, like condition as in chief complaint section, in the chief complaint section information is referred by a condition. If you go detail into the condition, it actually contains the content of the record. Okay, what is exactly the condition, and it is also a standard enables where SNOMED city is identified as a primary terminology. So the exact condition is represented using a standard. So if you noticed here, this section, using this section with enabled with terminology enabled and standardized data, we are achieving semantic interoperability, which establishes same meaning throughout the network or throughout the ecosystem. And this actually represent the syntactic interoperability, where we have fixed the syntax, and this is how you can generate a data. So this is how both the interoperabilities are achieved. Okay, so this is what is a computer understandable format, like program can read. Now whenever you will be presenting this document, this will look something like that. No course and nothing is visible. It is generated for the human understanding, human readable format. So all the so what all parameters that has to be considered whenever an application is generating the actual report, or UI, it is showing actual content. So this is how it can be done. So patient narrative is covered here. The composition narrative, which tells you about the author or who generated, being a practitioner, and its detail. The bundle will have a signature of author, which can be a signature of doctor, and whatever section narrative, which is the actual data, which is actual content in a readable format, is recorded here. So this is how we have mapped. What we have done is a reverse engineering, right? So we actually have this currently, and what we have done is mapped to the standard here, right? So this is how we have designed all of the HI types, which follows this same concept. There is a composition, there is a bundle, there are sections in the bundle, there are entries, and this is how we have standardized using FHIR for ABDM use case. Now moving towards the release updates that are there. So we have ABDM FHR implementation guide. Now we have a new build 2.5.0, where we have provided a new user interface that is available, whatever technologies we were using. So new template is there. We also introduce a history template to support to the previous build. So now here you will be able, I will take you through that also. So now here, as you can see in this screenshot, you will have all the earlier builds available, so that you can just go through it, and the work in progress build, where we can have what we are working next. Also, we have updated OP consultation record. We have updated in the sense, we have introduced new section, other observation, where all any of the observations or any of the clinical parameter that are not covered in that section, we have identified some of the parameter. Those are not currently able to capture data, so we have introduced this section. We have also updated the immunization profiles for WHO DDCC compliance, and we have also provided example to illustrate generation of immunization in DDCC compliant form. Then we have updated some of the resources to refer to the ABDM resources, and also we have added one value set for encounter type with a proper reference in the resource. So this is how I will take you through the so this is how a current bill looks like, and the profiles, as you can see, are all of the profiles are available here, and the history template that is new. You can access this here, where you can access all the history or earlier releases of the implementation guide. So now when it comes to help implementers and how those clinical artifacts can be generated or validated programmatically, we have given a sample codes, usage sample codes, where we are actually populating, creating, generating those clinical artifacts using open source library available, already available in the market, that is a happy. So we have provided this samples test code in our tools and technology sections in the NRCS. So you can go through. You can check our website, and under tools and technology section, you will find the FHIR ABDM implementation guide, which you can refer. And to further, demonstrate live, my colleague Gaurav will take you to the demonstration of these, how we are actually generating this FHIR implementation guide, right from how you can, populate the composition, the bundle. He will properly demonstrate you using a happy implementation library. And now over to you, Gaurav. Gaurav, if you can confirm, say hi, and let me confirm if you are audible or not.
I'm audible?
Yes, you
Yes.
are. Now
Oh,
over to Gaurav.
very good afternoon, all. My name is Gaurav Vaishnav, and I'm working as a project engineer with the National Resource Center for AHI Standards. And I will be demonstrating you the implementation of FHIR using the Java programming language. So for this demonstration, I will be using the FHIR library, which is also commonly known as the HL7 application programming interface. And this library falls under the Apache v2.0 licensing, and it is completely free and open source. Uh, and it is available free and open source on the Git public repository. So before we begin, it is important to note that we'll require to download full dependency of the FHIR library. So for that, let me share my screen first. Okay, so downloading the dependency of the FHIR library, I will navigate to the mvnrepository.com. Here we'll able to find the we'll search for the FHIR. So here we can see there are multiple packages are available of the FHIR. Among that will require the FHIR structure R4 for this demonstration. So this package will contain all the model classes for the all resource like patient, practitioner, observation, composition. So all the model classes will contain in this particular package. So I am just selecting the latest version of this dependency. I'm copying this snippet, and I've already created a Maven project into my ID. So I'm just pasting this into my Maven form.xml. So this is the first dependency which we required for the creating the structure of the file. Then the other two dependency which will require for this demonstration is the FHIR valid for the validation of the structure. So FHIR validation. So this is the FHIR validation. This package contain all the relevant classes that we require for the validation of the structure. So I'll copy this dependency also. Then the third dependency that we require is the FHIR validation structure resource R4. So I've copied all the dependency. So in this demonstration, I will be guiding you through the creation of the FHIR resources, and I will demonstrate how to serialize the resource and parse it, and I will showcasing the how you can validate a resource against the ABDM FHIR structure definition. So this for this objective, we this three dependency will be required for creating resources and the validation. Now, for in this demonstration, I will be creating a prescription bundle record. So, as in the last presentation, Shaili ma'am walked through us with the composition resource of the OP consultant node. In the similar way, there is a prescription record that is based on the composition resource. So, if we browse to the profile section of the implementation guide, we can find the prescription record. So, if I open this prescription record, so this is the composition record. So I will show you how you can populate this record programmatically. So I'll just split my screen into two parts. Okay. So I've already created a function with the return type of composition in my in my one project. So I have created a object for initialize the object for the composition. So I'll start populating this composition resource, because this composition record will be the header of our and our record. So if you are creating any bundle document, the first entry or the header element should be the composition. So if we look at the composition resource, the first element will populate is the ID. So this is the logical ID of this artifact, and this represents the unique ID of this particular clinical artifact. So in the how do we populate these values in our structure? So HappyFire library provide us the getters and setter for each and every element in this every resource. So for this ID, if you want to set the value for this ID, so I have to use the set ID element, set ID setter. So I'll just have a composition dot set ID, and I'll give the ID as the composition -01 as the ID of this artifact. Now we have the second element is the meta element. This meta element will tell us the metadata of this resource. So this meta element will have the version of this particular version ID of this resource. It will have the latest latest sorry, last updated date of this resource, and the last element is the profile element that will have the canonical URL of this particular resource. So if we are using the structure definition of the ABDM, so we'll have to provide this canonical URL, so the validator can validate against this particular profile. So if you are creating a resource of composition of the prescription record, so then we have to provide this canonical URL in the resource. One second. Okay, so I have to initialize a meta. In the meta, I have to set the version ID of this resource. So I'm just giving a one as a version of this meta profile. Then I'm giving the profile element profile. So this profile element will have the canonical URL as I mentioned earlier. So I'll just copy this canonical URL from here and will paste in the profile element. Okay, so now I have to add this meta element to my composition. So I just will use the set meta and pass the value of the meta to that function. Okay, then if I go into differential view, then we have the status of the, so status will tell about the current status of this particular composition resource. So we have four values of the status. So if so status may be preliminary of a final, amended, enter in error. So any of these four stages this composition resource can be in. So for setting this value, I just need to composition to set status, and this will take parameter as the composition status. Good. So for this populating, I am just using the final stage of the this composition. Then the other element is the type. This type element will tell us about the which kind of document it is. So in this use case, I am creating a prescription record. So this type will have the value as the prescription record. If the composition is of OP consultant or not, then this type may change. So for setting the type, it tells the kind of composition it is. So I just will use the setter for the set type. set type. Now it is a codable concept. Now what codable concept is? It is a complex type of data type which described by the FHIR itself. So it will have three values in it. So it will have the system. It may come from the any standard terminology which as in this case it is from the SNOMED city. Then we have this code from the SNOMED SCD ID of that particular record, then the display of this record. Okay, so we'll give the well initialize a new codable concept and pass the coding into it. So it will ask for the three parameters. The first parameter will be the system of the codable concept, which is in this case from the SNOMED city. So I'm just providing the SNOMED city.info/sct. Then the code of the SCT ID of the prescription record. So I'm just providing the SCT ID here. Then the last element is the display, which tells us it is a prescription record. So this element tells us what kind of record it is. So we have display. Okay. Now the other element, we have the subject. It is actually a reference to the patient, which tells you what is the composition and what record is all about. So the subject will have the reference to the patient. So we'll set the subject. It tells the who or what the composition or the prescription record it's all about. So I'm just setting the reference for the set subject. So this will have the argument as the reference value. So I'm just creating a reference. String reference as the patient. So what does this reference means? This the reference tells the resource/resource ID. So if we are if we the validator search or the traverse in the bundle record, so this will the URI of that particular resource in the document. So then we have the mandatory element as the date. So we'll provide the set date. This date will be the composition editing time. When was the this composition record is edited? So I will just give the present date for the composition dot set date and new date as the argument. Okay, then we have the author. Author will tell the who and what authored the composition or the record. Okay, so for the for this is similar as the subject element in the composition. Who and or what authored the composition or this prescription record. So I will give the reference for this author is, as the patient practitioner. It will have the reference in as the list. So reference as the resource name as the practitioner slash is resource ID. 5.01. This is the unique ID for each and every resource which will provide. So I'll just okay. Then we have the title element. Title element is the human readable text which tells the which kind of document it is. So in this case, we have the prescription record. So we'll set the title as the prescription record. So composition short, set title as the prescription record. So this is the human readable name and the title of this record. Okay, then the other element we have the mandatory element is this section. Now this composition resource is broken into multiple section, and each section have this section have the entries of the medical request and the binary. So this define the relevant medication request. This section particularly define the what medication request we attach with the composition request. Okay, so for section I will have to create a section component. Section, I'll create a section. Section component. So the if I go to the snapshot view, it will elaborate more element in the section itself. So we have two more element as the code and the title element. So I'll just set the, okay, making it short. So I'll set the section. So this code will define which section is for what this section is referring. So it is set to as the prescription record. So set code. This is again a codable concept. We'll have to provide the codable coding into it. So codable concept, new coding, which will again have the 3 input as the system, which will come from the SNOMED city. Then the SCT ID of this prescription record. Okay, and the prescription record. Now, if we look at closely in this resource, here we can see these values are fixed. This cannot be changed by our own. So these values are fixed for this particular composition resource, and other resource may have their different values in this particular section. And also the type of composition is also fixed because this composition refers to a prescription records only. So we'll have to check the values here also. Then we'll start populating up there. Now our section. Now the section will have the entries in the entry will have the reference for the medication request or the binary data. So for the reference, I will create a reference. So reference 1 will have the value for the medication request. So I'll just use this reference 1 dot set. So we'll have the first entry as the reference. So set reference. We'll have this string for the reference as the medication request. So I'm just giving the resource as the medication / medication. Yeah, medication request. This is the URI of the resources. I already mentioned in the earlier, like the validator will travels through this particular URI. So this is a standard standard way of writing this URI. So as the resource / the resource ID for the referencing. Then we have the reference dot set the type of the reference, which type of the reference it is. So in this case, we have also again we have a fixed value for this type. This must be a medication request. So this cannot be have any other value. So I'm just providing the medication request as the input. Then the second entry will be for the binary resource. So I am creating again reference. Here's the new reference. Then again, I will provide the reference to as the binary dot set reference as the string value. Now again, the resource name slash binary -0 is resource ID. Okay. Now again, we are setting the type of this reference. So in this case, again, we have the fixed value as the binary for this entry. So we'll give binary as the fixed value as for this type. Now I have to put this reference to my section component. So I'll just use the section dot add entry. This add entry element will have the argument as the reference. So I'll give the first reference and then dot add second reference dot entry. And then this section will have to add into the composition again, composition. So just we'll use the setter of the composition dot set set section will have the
Gaurav, excuse me.
Yeah.
Gaurav, I have one query. Is it okay if I can ask? Just now you're showing the comment.
Yes.
In this reference, this is when I am having my data in a structured format, fully structured format, right? When I have my SNOMED terminologies, etc., all set in my system. But when I am when my system is not yet ready for structured sharing the structured data, I have unstructured data, in the sense the prescription which is written in pen and paper by the doctor, that I am uploading generating a PDF format, and that I'm uploading. So can you just repeat, where do I upload in case of scanned picture? Which component I am uploading that?
Yes, yes. Meenakshi, to tell you that here we are not actually providing content, like जैसे कि क्या बीमारी हुई है या फिर what prescription में क्या medic आवाज नहीं आ रहा है?
Yes, I can hear. We can hear.
Okay. Here we are not standardizing content as such. What
Acha,
medication
okay.
is there, what medicines are there. We are just standardizing जो fixed values दिए ना, whatever fixed values are there ना, that is mentioning only the type of record or the section and you need not find it separately. That is already mentioned there. Your artifact should just include that, copy paste that. Now whenever you have already scanned copy, so in that case you will just upload that scan copy in a binary format in that entry binary. So
Okay.
binary section you will populate with the same data, because whatever terminology codes you are finding here is already given in that profile. So you just need to copy paste in order to provide a basic structure for that record. So that application can identify जो कुछ भी record आ रहा है, whatever record is coming, that is a prescription record. And for that we have made some fixed value which identifies which record is there and which can be identified using a standard terminology. And that is why these are fixed with the codes given. Now, when you want to scan and just upload, you will have this section, the composition, whatever properties that are set for the composition object, that will be same. You will just
that means in the medication request, is that
yes,
there?
yes.
I will put it in the binary form. Okay, got it.
In medication request, जो entry है ना binary, it accepts the actual byte array.
Got it.
Okay? So जो कुछ भी scanned है, you convert it into base 64 and just upload it. And if you ever want to have that record in a terminology standard form, you can populate medication request resource. right? And in that you can have in that you can simply have a text also, because it allows text only. And if your system is terminology enabled also, you can have coded data also. So while sharing also, even if you provide medication request or medication request, you populate medication request resource, you have you will get two provisions. You can simply write ki medication mein calpol diya hai, text format, or you can also write text with terminology. That
Got it.
So because
Got
if you see Gaurav, एक बार codable concept खोलना कौन सा तो भी
So for this,
explain करना.
I will have only this medication resource, right?
Yes,
For
medication
prescription.
request.
So is there any table wherein I can say, okay, for HI type prescription, this is the profile I'm using, prescription record. So for prescription report, I need to ensure that I use the resource medication in case I have my data, structured data. I'm
Yes,
going
yes. So profile
okay.
will tell you about the
Okay.
Gaurav is
Got it.
referring the same profile, right? Gaurav is referring to the prescription prescription record only, right?
Okay.
Prescription profile only he is referring to.
Oh, so yeah, sorry, my
Yes.
bad. I got it.
Okay.
In the same
Okay.
component.
No problem. No problem. So here is the official URL or the canonical URL we say, and he is referring to that composition which is designed for prescription. Like I mentioned, every HI type is a composition. It's bundled in a bundle, right? Bundle resource. So composition gives you the context कि भैया क्या मेटा डेटा है, कौन जनरेट कर रहा है, कौन सा पेशेंट है, and the composition will tell you about the sections which will tell कि what all information is covered. So in prescription composition, medication request will be covered because medicines are identified as a medication request. Denoted with standard. So if you want to populate medication prescription record, refer this profile, prescription record profile, where composition tells or metadata कि भैया ये prescription record है, और these are fixed value, ये तो आपको देनी ही पड़ेगी, right? And that is why we have given fixed value with URL and all, everything fixed. You need not find, search other way.
Got it. This will help define the structure of the
yes. So
record. So that is
so
that
basics, like I mentioned, we have interoperability. We have structured interoperability which can be achieved using syntax. And we have semantic interoperability where same meaning is to convey the same meaning. We have terminology standards. So this composition and bundle, whatever is there, is giving you the structural interoperability component, delivers the structural input, right? So like this,
I just have a follow-up question here.
Yeah.
On the Meenakshi's now, that initially when we have the document, right, it has different component prescription, but still it is a scanned document. It's in an unstructured format, right? So we have to convert that into an structured format, whether it's a text format, and then only we have to convert that into a binary, so that from there we can populate all the values which is required for this specific document. Then I think FHIR can identify that yes, this is a prescription format and this is the other sort of documents, right?
No. Actually, if you want to just scan that document, prescription document, upload, you don't need to fetch information out of it, right? The means AI NLP ये करके. So you just simply need to upload it here. Whatever data that you have scanned copy, you can upload here, and this structure remains the same. If at all you want to fetch information, what all medications are given in that prescription, then you need to apply image processing, fetch information out of it, and then you can have completely terminology enabled prescription record. And if you don't want to go that in first step, what you can do, you can populate the metadata in this way, and you can just upload the scanned copy here in the binary format. I hope it is understood.
Yeah.
So you don't need to fetch information out of it. This just represents the fixed value represents the type of record to identify if to be identified by any application which is receiving or sending that data. Okay.
Yeah, all right. Thank you, ma'am.
Okay, Gaurav, please continue. And all of this sample codes or whatever Gaurav is doing right now, it is already available in the usage samples, where each and every clinical artifact is programmatically populated and serialized. That all is already there in the sample code. So you can follow that also after this session. You can do a hands-on on that, hands-on with that usage samples, where you can have exact feel what we can test. If here Gaurav is demonstrating using a dummy values, what your application may be doing, you will first fetch it from the database and then feel that information. Whatever set he's doing, he's using dummy values. So in your application, you will be having one more layer which fetch information from the database and then populate. Yeah, Gaurav, please go ahead.
So I have one query here. Sorry to interrupt. So for example, let's take this information is supposed to be filled by a doctor or any hospital or somebody, and they fill the certain codes and certain informations related to outpatient or some SNOMED codes. After they save it, this will be converted into this structure, like FHIR structure, and this will be saved in ABBA, right?
ABDM.
Yeah.
So doctor, yeah, sorry, please go ahead.
So in that case, what is the URL that we need to save this structured data? Because we are forming it here, but how we send this data back to them, to ABDM?
So to clear your ideas, doctor will not enter SNOMED city code. A doctor will ultimately, you have to design and develop a end user application which will be either used by doctor or any healthcare provider or a patient. When a doctor is using some application, it will have a UI pages where information related to patient will be there, information related to whatever finding or diagnosis will be there. If a doctor is filling the prescription, information related to prescription will be there. So doctor will not enter SNOMED city codes there. Doctor will have a UI with simply text boxes. Maybe depends on the design of your application. It will have a text boxes where you can search medication, right? And it will have text boxes just to enter patient name. At the back end, all that information can be converted in the structure format as defined in ABDM using Happy Library in the FHIR format. So that code will be there, which Gaurav is telling. Actually, the UI will have that patient name. At the back end, composition patient resource will be populated, where patient dot set name will have name as a value. So that way you need to design your application.
No, front end I understood, because front end my query is not in the front end. I agreed. So it will be auto filled by backend, and that will be stored in ABDM. So, but what is the URL or something that we used to store? How do we store that information? We are forming a data set here with the model classes, and after that, how it will be stored in ABDM?
See, for ABDM, for exchanging data in ABDM, you have APIs of ABDM. There are HIP, HIU, depending on the whatever component that you have decided to develop. And using that APIs, you can transfer that data. ABDM is not storing any data. I mean, actually, if you can elaborate on this.
That's right. That's right, Sally. NHS server never stores any data. The gateway, whenever the data exchange is happening, it is happening directly between the entities, the healthcare entities, right? So to be specific, the data exchange happens directly between the HIP and HIU. So the gateway, our NHA gateway, it talks only to the repository, right? Or it talks to the patient via the CM, the consent manager, or HICM, what we call it. Never ever any kind of data flows via the gateway. The gateway just shares the notification, right? So any kind of data exchange, it happens only between the entities or between the entity and the patient. And when I use the word repository, it's nothing but it's the endpoint URL. It's the alias, the software what you are using. So there will be an endpoint URL which you will expose for communication and interaction with the gateway, with the end user via the consent manager, right? So again, summarizing it, so the NHA architecture, if you read the architecture, it's a federated architecture, right? Which means the data will always reside at the source. And the source here will be your entities, whether it's a clinic or a doctor or a hospital, any healthcare entity, right? Which is which will define itself as an HIP or HIU or both, right? So data never resides at NHA. Does that help with your query?
Yeah. Just correct me if I'm wrong. That's
Yes.
my understanding. I'll explain. So the data, whatever it's filled by doctor or any entity, that will be stored in their database or server. And after that, if it is required, it will form again a FHIR data for an exchange of a data or as an interface. And that data will be in FHIR format for an exchange between the entities or so and so. Either for a patient application also, it will be in that format, and same way it will be stored back in the entities
That is
facilities.
right. That is right. So whenever you initiate an exchange, whenever you initiate a health record exchange, so what happens is the HIU. I can just quickly share a diagram. I'm sorry, Sally. Just give me 2 minutes.
Yeah,
Okay.
sure, Meenakshi, no problem. Yes, go ahead.
Are you able to view my screen?
Yes.
Yes.
So if you go to the sandbox abdm.gov.in, I sincerely request everyone to, I know the documentation is not very well done. We are working on it to improve that. But you can go to this architecture page. So what happens here on the right side, you have your HIUs, and here you have on the right side, you have your HIPs. So what happens whenever an HIU, it seeks to view a patient's record. So what it does is it tells it to the repository, right? The repository then sends the information to gateway saying that this is the particular ABHA address which I have been shared, and we would like to, the HIU would like to view the records. So this gateway then sends it to the user via the consent manager, because the consent is required for the patient. When the patient gives consent, so this gateway notifies to both the HIP as well as HIU, but it does not interact directly with the HIP and HIU. It always interacts actually with this repository or the HRV layer which is there, the endpoint layer which you have exposed, or the solution what you are using, that, right? So and then this repository then communicates with the HIP, how that is internal between the facility and the HRP, right? And then what happens is that the HIU, the HIU or the repository of the HIU, it then initiates a data push URL, which is then shared via a gateway to the HIP. And then the data transfer flow happens directly in that data push URL from HIP to HIU. Nobody is involved in between. So NHA server will never know, what kind of data is just sent, or what is the size of data, or how many care contexts is sent. Nothing is sent. So if you see the architecture, this red line, it denotes the data source, or the data flow. So if you see the data flow, this red line, it is never via the gateway or never via the consent manager, never, right? It's just the gateway is interacting only for the user interaction, or some kind of control flows like consent management, etc.
Okay.
Does that help?
Yeah, it helps a lot. And here my question is, the repositories that is mentioned here is the entities repository they maintain, and whenever it is being a request is sent, and the response will be sent back. right?
That is right. That is right.
Through a
The
gateway
HRP,
with the
that is
consent manager.
that is right. HRP is basically most of the cases it will be the solution provider, the software solution provider, the digital companies, who provide HMIs, LMIs, or any kind of solution. So they might act as an HRP. Sometimes it is an in-house, right? So that is why I did not use the word solution provider, and that is the reason why I use the endpoint URL or the bridge.
So simply said, data push URL is basically exposed by health repository provider, HRPs.
That is correct.
Ms. Meenakshi, can you complete the flow of medication request with an example? Else we are breaking the.
Yes, that's Sayali and Gaurav. They will be taking up now. We diverted a little on
Yes,
the
yes.
data flow.
Yes,
So
we
Sayali,
lose the flow.
you can please continue, Sayali.
Yes. Gaurav, please continue.
Sorry, Gaurav, I sincerely apologize.
No problem. Ultimately, queries should be resolved. Share kar this.
Hello, am I audible? Yeah. Now our composition resource is now ready and completely populated all with all the mandatory field for all those elements which have the cardinality 1 to 1 or the 1 to star. So all the mandatory fields are populated in the composition resource. Now we'll populate the reference resource that we have given the URI in this composition resource. Like we have given the URI for the patient, we practitioner, medication request, and binary. So I already created this resource for saving the time. In the similar way that I have populated the composition, I have using the setters and getters, I have populated the patient, and in this resource I have populated all the mandatory element of the patient. Like if I go on to the patient resource. So here this is the patient resource. I hope it is visible.
Yes.
So all the element that we have the cardinality 1 to star or 1 to 1, that means it is the mandatory element, mandatory field or the mandatory element in this particular resource. So if I talk about the patient dot identifier, then it is the mandatory. So I have populate all the required element, minimum required element in these resources, and these resources are actually being referred in this in the composition resource that I populated earlier. And now we'll see how this all the resources will enter in a complete bundle. So
Gaurav, sorry to interrupt you. Can you please show the medication request resource as well, so that they will have a clear idea how to populate a medication resource with. So when you see medication resource here, so see, someone was asking how to, give a medication with in a certain example. This is the value which is coming from the SNOMED city or the CDCI, if you are aware of common drug codes for India. This is the medication that is given for once a tablet with food or without food, that instruction are covered. So all these instructions and all these related information is covered in the medication request. So if you follow the medication request resource, करो एक बार open करना medication request resource. Medication request. So under medication request, you will get all those elements that you need to right from the coded information of medicine, how many times it should be given, all that can be populated here with the medication request resource. ID खोलना. So here you can see all that information that one of the user implementer was asking. This is how a medication request, for the sake of time and complete it on time, we have already a populated resource with all its mandatory fields with standardization enabled also. So whenever you will have application, you will have we will be having a field where medication can be typed, and we have tools. Our CSNO TK tool will help you to find through the standard medication that are coming from common drug codes for India. So if you have integrated SNOMED CT, which is a toolkit which gives you API to integrate SNOMED CT enabled terminology as well as medications. So with the help of that, you can enter your medication in a standardized format which allows not only medication in a standardized format, but also route of administration, then form, how to take it, the directions to use, once in a day, twice in a day, all that can be standardized using SNOMED City. So that is how you can also populate medication request with standard. Okay, Gaurav, continue with your presentation.
Hello. Yeah, I have one question here. So,
Yes.
suppose one HIU has requested data from Jan 1st to till date. So,
Your
patient ABC has visited 3-4 times for this period, like January 1st to till date. There are around 3 prescriptions are there.
yes.
So how we can prepare? Like we need to prepare 3 bundles or
Yes.
3 bundles, or in one bundle we need to give 3 medications.
Currently, we are expecting a single bundle for single prescription.
Okay. Yeah, good. Okay, thank you.
Sorry, I'm just going to put in a quick request. Can people please mute themselves? It's really hard to understand the conversation. I believe this Mr. Varun Singh. If you can please mute yourself. Thank you.
Yes, Gaurav, please go ahead.
Okay, now till now we have populated all the relevant resources be required for the prescription record. We have patient, we have practitioner ID, we have medication request, and the binary resource. Now I will put all. I will see how.
Sorry to interrupt you, Gaurav. Can you please show how binary is populated, and where that, even though we have dummy data right now, so where we can see so binary set data element, new base 64. Here the complete binary for that record can be entered, can be set. Okay.
Hello.
Yes.
Yeah. Yeah. So I have one question. Like, I'm Kevu Savalia. Okay. So here I have one question related to binary. Okay. So actually, this is the only way that we can create a PDF in this binary format, or like I'm just I have one question like regarding like I have a PDF with me. Okay. Which is like I have given to the patient. Okay, and I have given that PDF to the patient. So I have created that PDF in a binary format, like in a base 64 format, and I am using like I have attached that base 64 into the document reference. Okay, there is also
a document reference.
Yeah. So is it fine if I can use document reference and I have sent it that PDF in that section, or I have to use this binary only?
Actually, for the sake of simplicity, we document reference resource has more elements that it the document reference defines the context also. It has other elements. So to reduce that complexity for the sake of prescription, we have used binary here. So you just don't need to populate that whole document reference. You just the attachment in the I guess in documents
Yes,
reference,
yes,
attachment is the element,
yes,
right?
yes,
So
yes.
whatever data that you are giving to the attachment element, that you simply can give it to binary for the sake of, because other metadata कि किसका prescription है, कौन सा doctor है, that is already there in the composition.
Okay.
So you can simply use binary in prescription.
Yeah, I have used that document reference as I don't have a structured data because the SNOMED set is not implemented in the system. So that's why I have used that document. Okay,
Yeah,
that's
no
fine.
problem. But
Yeah.
but for the ABDM to generate that
Yes.
prescription record, na, you will
Yes.
have to use binary.
Oh, so you mean to say that if I use a document that it will not show the my PDF into that particular PHR application or
But
something?
where you are referring to that document resource reference, because what we have referred in the entry is a binary.
Okay.
Right. So that document record resource should be referred somewhere, na?
Yes, 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 yes.
Yes.
Actually, I
So
have
that is
created a
not
bundle.
there.
Yes, yes, yes,
Yes.
yes.
So that is not there in prescription. So in prescription, only binary is there. And that is a subcomponent of a document reference. So you don't need to have that complex resource populated there. Simply just attachment में जो कुछ भी आप value दे रहे हैं, आप binary को दे सकते हैं यहाँ पे.
Okay. Yeah.
Okay.
Yeah. Thank you.
Yeah. Gaurav, please.
Okay, now we'll continue with the resources. Now we populate all the references. Now we'll see how to put all these resources in a bundle resource. So similarly, like composition, I have created this bundle resource, populated the bundle resource. So if I open the implementation guide side by side for the bundle, so we have also profiled bundle resource. So this will have the meta, identifier, and type. So these are the only element which are mandatory in the bundle. Then similarly, we have given the ID for the composition. In similar way, we have described the ID for the this prescription bundle as the prescription bundle 01. Then we have the meta prescription bundle. We are getting the reference of the meta, then version ID as the 1, then last updated, and here we are giving the canonical URL of once again. So here we are giving the canonical URL of the bundle resource. So as in the composition, we have given the canonical URL of the prescription resource. So similarly in this as this bundle resource referring the ABDM profile of the document bundle, so we have to provide the canonical URL of this canonical URL as the profile element. Then we have the version independent identifier of the bundle. And similarly, we had set the type of the bundle as in the ABDM ecosystem. We are referring the document paradigm for the interoperability. So therefore, we have fixed the value of the document type as the bundle type as the document. So I just provided the bundle document here. Then the timestamp when was this particular document is created. Time is now now I will listed all the entries. Now if I open any example for the example in the implementation guide for the prescription record, here we can see this is a JSON object of bundles looks like. So we have the entry as the first entry as the composition, then we have this second entry with the patient, all the reference element that we have populated now and the reference URI given in the composition will have to add into this bundle resource. So this is how an entry looks like in a JSON format. So we just in the happy we have creating just list of bundle entry component like we have created earlier in the section of the composition resource. So we have created two sections for medical request and the binary. Similarly, we have to create the list of bundle entry component, and in that component, in the bundle entry component, we have to pass the resource. So first we have to give the full set full URL, as we are populating all the reference resource in the in the bundle itself. So we need not to provide the complete URL. We just have to give the URI as we provided earlier in the composition. So the standard format is the resource name / resource ID. So when the validator will traverse each entry, it will find by this particular URI. So similarly, we have the second entry as the patient. So we just set the URL as the patient / patient hyphen u1, and this will fetch the populate patient resource function. So similarly, all the resources are being populated in the bundle. So I'll just 1 second. So I'll just show you how we can see encoded this object into FHIR structure. So now we have just a Java object. So now we'll see how to convert this into convert or serialize this object into FHIR object. So for that, I need to initialize a context, FHIR context, which tells which act as the factory for all the interfaces in the FHIR. So this is the FHIR context. Content dot. Now we have to provide which version we are referring. As in the ABDM, we are stick to the version R4. So I am creating a context for the version R4. Now I will create main function. In the main function, we have to create a parser for the conversion of the Java object into FHIR object. So in the Happy library, there is one interface available for the parsing. It's the iParser. So I have created a parser element, and we'll use the context. And we have two APIs as the new JSON parser and the XML parser. In which format we want to serialize this structure, we can choose among these. So I'm for this demonstration, I will creating into the JSON format, and I will setting it to pretty for formatting. The API call is set. Pretty is the input as the Boolean input. Okay. Now I'll give this value to the string parser dot encoded. So this will encode resource to the string, and I just need to give the description bundle dot. I've passed the resource object to the encoded this API. Then just need to now I'll print this system. Now we can see here, just to run this Java file as the Java application. If I see the output, we have successfully created a resource bundle. So all the populated element we can see here. This is how parsing parsing or the serializing done in the Happy library. Now we have the complete bundle, and the first element as the composition, which is a prescription record. Then the second element the patient, and so on. So this is how parsing done in the FHIR as a Happy library. Now we'll see how validation is done in the using the Happy library against the ABDM FHIR structure definition. So before going to the validation of the FHIR structure definition, FHIR profile resource, So I will need to download the npm package from the implementation guide. So if I go on the home page of the implementation guide, on the tab, on the navigation tab, we can see a download section. Under the download section, we have the package file. So the package file contain all the structure definition that we have profiled in the ABDM FHIR implementation guide, and the value sets we have created. So so I will just put this package.tzz file. So already downloaded and put into the my src/main/resource. So here I have to put the completed this file, which contain all the structure definitions, value set that are created by the created for the ABDM. Now we have the now similarly we have the we start creating a context for the validation. So for validation, we also require the FHIR context. FHIR context. For R4. Now we have to load the package from the as we have put the package at the class path. So we have to load this package into load the package.tar file. So for that, we have one API is the npm package. npm package validation support. This API will help us to load the npm package. So we need not to direct provide the structure definitely individually. So if we have we can provide the complete package in one go. So this API takes the parameter as the context of the FHIR. So we have provided as a CTX. Then in the npm package, there is one method is there. This is as the load package from the class path. So now we have to provide the class path and the package name. So here we have the package name as the package.tzz. Package.tzz. Okay. So now we have to create a validation chain. For validation, we need the default profile that FHIR has the base profile. We require that profiles. We require the terminology support of the like value set and code system that are provided by the HL7. So for that, we need to create a validation support chain. Validation support chain. In that validation support chain, we have to pass this npm package. In this validation support chain, we have to pass the npm package package support npm package validation support. Next, we have to provide the default profile validation support. So we provide the base structure definition over which the ABDM FHIR profiles are created. So default profile validation support, which will have the parameter at the context of the FHIR. Then we have the common core terminology. Common code system terminology, which will provide the code system that are in the HL7, that are provided by the HL7. and in-memory terminology server, which will help us to validate validate our codes against the terminologies or the value sets that are in the that are be provided in the by the HL7. So in-memory terminology server. So in this one second. So in this, there are only we are validating against the HL7 value sets only. We are not validating against the Snowmeshcity codes because the Snowmeshcity codes is very vast, and in the simple APIs it's not able to fit in. So if we want to support Snowmeshcity or the belonging other code, you have to add any terminology server to your code. So you may add a remote server to this. Okay, then we have the snapshot generator. This will help. This will create a snapshot from the differential view. If you are structured definition only have the differential view, like in the profile we have seen the differential view and the snapshot view. So if your structure definition or the XML file of the structure definition do not have the snapshot context, only it contain only the differential view, differential elements. So this API will generate the differential snapshot view from the base resource. Now we have created a validation chain. Now we'll cache. We'll cache this validation support chain. Now we have to now we have created a validation support. We have load the package which have the structure definition, and we have cache all the APIs. Now we have to create a validator for FHIR validator, which will validate against these structure definition that we have provided. So there is one interface available for the validation. So it is a FHIR validator. Will have the context as the new validator, and then we have to provide an instance. Then we have to provide an instance validator that will validate against the structure definitions. Instance validator. So new file. What's set? And we have to register this validator. So these are the mandatory steps we have to follow for validation. Register validation module and pass the parameter as the instance validator. Second. Okay. Now we have completed all the steps for required for the validation. Now we have the validation result out. Validation result, which will print out all the errors and warnings that found on the during the validation. So validation result. setting is outcome validator dot validation with result. So there we have to provide the resource. Now we have the prescription bundle resource. So I will just provide the prescription dot in the argument and create a for loop for printing all the messages that occur during the validation. So we have the single validation API, single validation message. Next dot dot get message and sys out. Now we'll print the severity first. Is that the output is coming is a error or a warning or maybe an information. So we'll just print the severity. Next dot get severity. Then we'll print this next dot the location of the error. Location string. And then the message exact message. Now, if we have populated correctly, this will not give any error. Or so I just run this as the Java application. Okay, so there's one dependency is missing, I guess. One second, just replace this file with another one. Miss out something.
Excuse me, I think in the pom.xml, the first and last dependencies are same. I think there's a mistake there. Look at the third dependency.
Yes, I missed one dependency actually.
Yeah.
Thank you so much. Happy FHIR structure validation R4. This dependency will require for the validation. Now our the resource is validated. It is given a message as the is successful true, and there is no issue. So if I miss out any like I will just yeah demonstrate the failure case. Like if I miss out the composition composition will not provide the composition resource as the first entry, just missing this entry. So this should give an error. So this element has given the error and error string that the document must have the composition as the first resource and the composition the first entry of the medication this resource. and the medication resource medication request URI is not isn't reachable for that. So this is how the validation works. So if I miss any mandatory element for the ABDM structure, so if I go on the structure definition for the document bundle, so here we can see the identifier of the bundle. So bundle there is identifier element is the mandatory element. So if I miss out that element, it should give the error to me. So here we have the identifier, and I'm just commenting out this identifier, and we'll run this. So we can see here we get the message. The document must have the identifier as the system. So this confirms that we are actually referring the URL, canonical URL of the bundle, which have the version of 2.5.0, and it have the minimum required identifier value as the one, but we have not provided any identifier in the bundle resource. So this is how validation works. So now if we in the other use case, if we have simply a file that we want to validate against the this validator, we so I will just download any bundle resource from the implementation guide. Just we download the prescription. Okay, take another example, OP consultant node. So we have JSON structure ready here. So I just download this structure, paste into my. So here I downloaded a bundle of the OP consultant node. So I'll just in the validation I have created is we have to simply read from the file. So for in the FHIR there's single interface is used for the serializing and deserializing. So we need not to use any other any other API. So we have similarly, like we have serialized, we have deserialization of the resource. So just provided the ask for the file path, read the file path, and created a parser with the context of the new, JSON parser. Then we have in the serialization we have encoded the resource. We're parsing the resource, and we are just using the file IO operation, file reader, and we are passing the argument as the file path. So I'll just create the resource. Call this function into my main. Let's run the. So it is asking for the file path. I'll just provide the copy path of this resource and paste here. So we have successfully validated this resource. So we have no issue with this bundle. We'll try to create the issue in this if like in patient will miss the identifier, as it is also mandatory in the patient resource. So if I miss the identifier and try to validate this in this in the file path. One second. Okay, I made changes in the wrong file actually. So the patient. Patient, we have identifier element, and just remove this element. Okay, now we'll get the path. So we got multiple error for this missing identifier, because this patient is again referring into different profiles. So everywhere the patient is referred, at that point it given the error to us in the composition, everywhere where the composition is referred. So this is how validation work in the FHIR. So that's all from my side. And
Yeah, hello. Yes.
yeah.
Give this side. So I have one question this for this validation. So my first question is like, can we use that any online validator, like as like I can see there is a one online validator is available in the documentation. So can we use that validate like that online validator to validate our created FHI?
Yes, you can. The CLI tool validator, right?
Yes, clinical FHR. Yeah, I
Are
have.
you talking about the Inferno Health Validator?
Actually, I have given you the URL in this chat window. So can you please confirm? Because
Okay,
I have.
unless and until, yeah, sure, you can use any validator unless and until it is validating against the FHIR artifacts for ABDM that we have designed. So if the validation is happening against our profiles, then it should be fine.
Okay. Okay, and my another question, like, is there any library available in C# that validate this FHR, the same thing that you have mentioned in the as a Java validator? In the
Okay,
Java?
okay. So actually all the open source, Gaurav, वही page खोलना अभी जो खोला था, open implementations, all the open implementations. So this Confluence page list all the implementations available, including Happy Library for different languages. So here you can go and check. We at our end haven't hands-on on every implementation. So you and your team can do, and if in case you find any,
Yes, got it.
let us know. Yeah.
Thank you.
So I have pinged this, posted this link in the chat also. So all the implementations, including PHP, JavaScript, it is mentioned here. Any other queries, doubts? If you have any further queries also, you can email us at nrcs-help@cdac.in in term if you have any queries related to standardization. And only binary section entry you can fill. You can refer to the only binary. You first refer to the profile where you will get what all mandatory is there, and
Right.
only pick and choose those resources or elements.